Envision a weapon more accurate than anything previously imaginable, able to hit at the speed of light, more powerful than anything previously imaginable, able to destroy hypersonic missiles mid-air, and revolutionary enough to render conventional warfare an obsolete concept. What if the future of global security depends on making this weapon part of the world's most advanced warship, the USS Gerald R. Ford? But here's the catch. To accomplish this breakthrough, you must solve an engineering problem that is as difficult as it is critical. The U.S. Navy to overcome these challenges and enter a new era of dominance? We are at a crossroads in military technology. Conventional weapons, missiles, bombs, guns do the job, but they have limits. Munitions get used up, delivery systems can be intercepted, and the costs of deployment go through the roof. So enter directed energy weapons, or laser weapons, as they are more commonly called. Laser weapons also are fast, accurate, and virtually inexhaustible as long as they have a source of power. But therein lies the rub: power. These futuristic weapons use massive amounts of energy to function. The vast majority of ships, even modern warships, simply don't have capacity to generate enough electricity to power a high-energy laser weapon system without degrading other capabilities. This is where the USS Gerald R. Ford, the most advanced aircraft carrier ever constructed, pays dividends. In order to accommodate such energy-hungry systems, the Ford-class carriers are powered by two utilized A-1B nuclear reactors that can crank out a mind-boggling 700 megawatts of electricity, more power than any other ship currently in service is able to host. But how did we get here? And even more critically, where the hell are we going? It's been only a few decades since laser beams have transformed science fiction and military sci-fi. Laser weapons have been a holy grail of science fiction for decades, but realizing that vision has been a lengthy and tortuous process. The US military first started to explore laser technology in earnest during the Cold War, fueled by programs like the Strategic Defense Initiative, SDI, or Star Wars, as it was popularly called. Although SDI never achieved the lofty ambitions it once had, it set the stage for future advancements. The US Navy deployed its first operational laser weapon, AN/SEQ-3 Laser Weapon System, LAWS, on the USS Ponce in 2014. This 33-kilowatt system was designed to target and destroy small drones and boats. Still, it was a far cry from the high-energy lasers needed to confront advanced threats, such as supersonic and hypersonic missiles. Since then, the Navy really has been pushing the envelope, creating systems such as HELIOS, high-energy laser with integrated optical dazzler and surveillance, and HELICAP, high-energy laser counter ASCM program. These aim to generate beams of more than 300 kilowatts. Enough to zap fast-moving, armored perils out of the sky. It faces a common bottleneck, however: energy. The power problem. The USS Gerald R. Ford is all about power. To see just how big a barrier power is, think about this. A high-powered laser weapon requires tens to hundreds of kilowatts of energy to function. That may not sound like much compared to the Ford's 700 megawatt card on the table, but energy on a ship is limited. It's not just powering the weapons, it's also running the ship's propulsion systems, radar, communications, and aircraft launch systems. Most contemporary war vessels employ gas turbines or diesel-electric systems, which output far less power than a nuclear reactor. For instance, the conventionally powered HMS Queen Elizabeth generates a mere 72 megawatts, less than 10% of the Ford's output. And even France's second most powerful nuclear-powered aircraft carrier, Charles de Gaulle, generates 400 megawatts, 57% of Ford's output. This difference makes the Ford effectively the sole feasible base for developing and deploying high-powered laser weapons in combat. USS Gerald R. Ford, a technological masterpiece. The Ford's two A-1B reactors are a major upgrade from the Nimitz-class carrier's A-4W reactors, generating almost 3 times the energy. This not only allows the ship to fully power energy-intensive capabilities such as EMALS, electromagnetic aircraft launch system, during flight operations and advanced radar, but also to operate the ship itself without being limited by a lack of generating capacity. Ford was built with an eye towards advancement. Its electrical grid was deliberately over-engineered to support future technologies, like directed energy weapons. Such foresight means that, as laser tech advances, the Ford can easily adopt these systems with little major retooling. The Ford is a fortress at sea, even without lasers. It carries an array of advanced armament, including CRAM and ESSM, developed for intercepting incoming threats at extended range. Phalanx CIWS, close-in weapon systems, a last-resort defense designed to fire 4,500 rounds per minute. The laser weapons would enhance these systems, adding a defense layer against new threats such as drone swarms, hypersonic missiles, and stealth aircraft. Laser weapons, the game-changing capabilities. Laser weapons are special because they move at the speed of light, about 186,000 miles per second. That makes them the fastest ever invented, able to strike a target almost instantly. In contrast to conventional weapons, lasers can focus their energy on a point targeted at a specific location, allowing for surgical strikes that minimize collateral damage. This level of precision is critical, especially when neutralizing high-value targets, like sensors or other components on an enemy missile. Conventional arms depend on those same limited munitions, which need to be restocked during protracted missions. Lasers, on the other hand, create their ammunition from onboard energy, effectively enabling them to run with an infinite magazine so long as power can be provided. The electricity to send some photons blasting through the air costs only a few dollars. Compare that to tens of millions on a missile or a torpedo. This offers lasers efficiency and economic wisdom in extended battles. Unlike guns or missiles, lasers shoot without sound or flash and are therefore nearly impossible to detect. This stealth ability is vital to conducting covert missions and erasing an enemy's potential to respond. Challenges and the road ahead. Creating a high-powered laser generates enormous amounts of heat, which must be routed and dissipated to prevent damage to the weapon itself. Engineers are working to overcome a critical hurdle of this advanced property, developing advanced cooling systems. Although lasers zing with speed and precision, they use advanced sensors and targeting systems to detect and track dangers. It is not an easy job to integrate such systems into a coherent defensive network. As laser technology improves, countermeasures will as well. Adversaries can create reflective coverings or evasive maneuvers to reduce the effectiveness of laser assaults. The global race, getting everyone else up to speed? China is investing heavily into laser tech right now with reports that they have what it takes to test systems on ships. But without nuclear-powered carriers, they lack the same power as any other country. While Russia has technologically advanced military capabilities in some respects, the country remains well behind in both carrier design and directed energy weapons development. Allied countries such as the UK and France develop laser systems, but their conventional propulsion limits their application in deploying anything high-powered. This is what laser weapons mean for the future. If successfully deployed, laser weapons would change the era of naval warfare. They will ensure U.S. naval dominance advancement, ensuring Navy leadership in tech at sea. Transform strategic frameworks. Move away from dependence on costly, limited munitions towards flexible, energy-oriented alternatives. Deterrence of adversaries. Signaling to prospective adversaries that the United States remains at the vanguard of military innovation. What do you think? Is the future of naval warfare laser weapons, or are there undisclosed challenges? Tell us in the comment section below. If you liked this deep dive into the cutting-edge military technology business, please like, subscribe, and hit the bell notification for more in-depth analysis.